Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today I'm going to be working through a series of 6 problems to help one of my students get ready for his exam. Please put questions in the comments, and feel free to post more problems down there as well. On to question number 5. Use the values for f of x and f prime of x at x equals 0, pi over 2, pi, 3 pi over 2, and 2 pi to sketch a reasonable graph of f of x equals x times the cosine of x. So what we're going to be doing is coming up with a series of x and y values, so points, and then the derivative values at those points, which is going to tell us what the slope is doing at that point. And we can use that to then kind of get us a good idea of what the graph is doing. So let's go ahead and find the derivative for this function first. And there's several things to do. We've got to find the points, we've got to find the derivative, and then the values at the derivative. So I think it's probably easiest just to go ahead and find the derivative. So f of x is a product of two different functions, x and cosine of x. And so we're going to be using the product rule here to find the derivative. So if f of x, our function, is the product of two functions, so g of x and h of x, then f prime of x is going to be equal to, well, it depends on your book's definition, where your teacher's done it, but in general, you're going to be taking the derivative of one of the pieces, multiply it by the other, and then add the reverse of the two. So in this case, we're going to be adding g of x times h prime of x. Okay, so if f prime of x, or if f of x is equal to that product, then let's identify g and h first. So g of x is just going to be that first x, and h of x is going to be the cosine of x. G prime of x, well, the derivative of x is just 1, and the derivative of cosine of x is negative sine of x. So let's go ahead and put all that together. So f prime of x is equal to g prime of x times h of x, so 1 times the cosine of x, plus g of x times h prime of x. And we'll simplify this down so we can use it. So f prime of x is equal to cosine of x minus x sine of x. So let's go ahead and get a table going now with all the values we're going to need. So we've got f prime of x up there. Let me go ahead and write up f of x. And let's go ahead and build a table. Okay, our table is going to have 3 columns. We'll have our x values, our function values, and our derivative values. Our x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I plug 0 in to f of x, well, I get 0 times cosine. So it doesn't matter what cosine is, it's just going to be 0. If I plug pi over 2 in, well, cosine of pi over 2 is also 0. So that's just going to give me 0 as well. If I plug in pi, though, cosine of pi is negative 1. So the function value is going to be negative pi. If I plug in 3 pi over 2, well, cosine of 3 pi over 2 is 0 again. And if I plug in 2 pi, well, the cosine of 2 pi is 1. And so 2 pi times 1 is just going to give me 2 pi. All right, now the derivative. It's going to be a little bit more complicated. If I plug 0 in, I get cosine of 0 minus 0 times the sine of 0, which is going to be equal to 1 because the cosine of 0 is 1. Next, I'm going to have the cosine of pi over 2 minus pi over 2 times the sine of pi over 2, and that's going to be equal to the negative of pi over 2 because the sine of pi over 2 is 1. Next up, we've got the cosine of pi minus pi times the sine of pi. Sine of pi is 0, so that means we'll be dealing with the cosine of pi, and that's negative 1. Cosine of 3 pi over 2 minus 3 pi over 2 times the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so that becomes positive 3 pi over 2. And lastly, cosine of 2 pi minus 2 pi times the sine of 2 pi equals, cosine of 2 pi, because the sine of 2 pi is just going to be 0. So the cosine of 2 pi is equal to 1. Okay, so those are all of our values there. And from that now, we should be able to go ahead and graph all of those. So let's go ahead and set up a coordinate plane. And give myself plenty of room along the x-axis. Go ahead and label your hash marks. Okay, so the first thing I'm going to do is go ahead and put in my points. And those will just be dots. So we've got 0 at 0 and pi over 2, negative pi, which is about negative 3, 3.14. At pi, 3 pi over 2, we're back at 0. And then at 2 pi, we're at 6. And 2 pi, we're at 2 pi again, which is about 6.28. So we're up here. Okay, so now I'm going to put my derivative values down. And the way I do that is I use a line through the point, something like that. That's going to show me the slope. So the slope at 0 is going to be 1. And so that's going to look, it's positive, so I'm going to look something like that. The slope at pi over 2 is going to be negative pi over 2. So we're going to be negative in the negative direction, something like that. At pi, we're going to be negative 1, which is a little less negative than negative pi over 2. And then at 3 pi over 2, we're going to have a slope of 3 pi over 2. So that's going to be fairly steep. And then at 2 pi, we're going to be back to a slope of 1, something like that. Okay, so now the function's got to be continuous. How do I know that? Well, because it's the product of two continuous functions. Both x and cosine of x are continuous, and so their product is going to be continuous. And so if I look now, I have to make a smooth transition between these points. And my slopes have to match up as I get there. I don't have to be precise necessarily, except for at those points. I better get back to those. And things are going to line up nicely. So here I've made a graph in Desmos and clipped it out of the window there. And as you can see, our graph looks very similar to the graph that we created. And we can see some of the key points. There's 0, there's pi over 2. Pi is going to be right about here. 3 pi over 2 is right here. And then 2 pi is right about here. And so you can see that our points and our derivatives line up. And that should be the end of the problem. Thanks, and I'll see you in the next video.